G'day and welcome to Building Australia. Today we're going to look at different types of construction methods in the context of a certified passive house. Joining me today is Peter from SmartSIPS. Today's show is sponsored by SmartSIPS. Let's get started.
Yeah, thank you, Andrew. It's great to be here.
What's the big difference between a SIPS construction and a conventional house framing?
Okay, well, I'll just pop this sample
Sure,
up
let's have a
on
look.
the desk.
So this one is a sample floor panel, is that correct?
Yes, it is. Yeah.
Yep.
This is slightly thicker than a normal floor panel.
Yep.
Normally we'd range a floor panel from a 210 thickness.
Yep.
This one's a 260 millimeter thickness.
And this is a similar sort of build up to conventional bearers and joists, only it's a whole system. So structure, insulation, all in one.
That's correct.
Yep.
Yeah. So typically the ground floor SIPS panels will be placed on a bearer.
Yep.
And in standard construction with floor joists and yellow tongue flooring, the bearers are 1.5 meters apart.
Yep.
So this flooring allows us to go 3 meters apart on your bearers.
Long spans.
Yeah.
Much bigger than a conventional bearer and joist situation, which means a lot less impact on the ground, less footings, less stumps, whatever you need, absolutely minimal impact.
That's correct.
Yeah. And we've got here one of the structural cores, a bit of pine that would otherwise tuck in there. So it's not just the OSB and the core. What else goes into this, Peter?
So we have our joining members.
Yep.
And so we'll put 2 joining members on each join on this side.
Sure.
And we call them a spline because they're joining 2 members together.
And this is acting a similar way to a floor joist.
That's correct.
Yep.
And so being a structural insulated panel, we rely on firstly the spline. So we've got 2 38 millimeter timber joiners on each join, 1200 millimeters apart.
Yep. So you're effectively getting a double joist every 1200 mil.
Yep.
Yep.
But the real strength in structural insulated panels is they works very much like a universal beam.
Yep.
So the top skin is and the bottom skin, one's in tension and one's in compression, depending on how the SIPS is engineered.
Yep.
And so the one skin's pushing and pulling against the other, exactly the same as an I-beam.
Yep.
And so we combine the diaphragm of the top and bottom skins with the spanning capabilities of the double spline, and we can reach spans. So this is why we can reach the span of 3 meters as opposed to
1500.
1500, yeah.
Yeah. So going back a little bit, when we think of tension and compression, in this case, a little bit like a concrete slab, we've got this compression coming down, which is the load through normal use of the house, the external walls, and then the tension underneath is this wanting to stretch, isn't it?
That's correct.
And which is where this core underneath, unlike a conventional floor frame, is eliminating that, really, isn't it? There is no stretch.
That's correct.
Yep.
Yeah.
Yep.
And then in the one action, you're putting in your floor joists, your yellow tongue, and your insulation.
And any connecting hardware as well.
Yeah.
It's all there.
Yeah.
So what about this core, Peter? What's going on in here?
This core's quite a different material from what you'll normally traditionally find in structural insulated panels.
Yep.
So SmartSIPS, we've done a lot of research into core material.
Yep.
And we're members of the SIPS organisation in the US, so we pick up a lot of the research that they've done.
Yeah, which is also where it's much bigger and more established. Compared to Australia, we're still catching up a bit.
We are, yeah. They started using SIPS in America in 1950.
Yeah.
In fact, the first SIPS home was built in 1923 by Frank Lloyd Wright.
Yeah. So a bit of history, a bit of context about the lifespan capabilities of this sort of construction as well.
That's correct, Andrew.
So the difference here also, I think, as you mentioned, this is a graphite-based polystyrene compared to XPS or EPS. What's the reason for that?
Okay, so BASF set out about 7 or 8 years ago to do research on how to improve the insulating properties of standard white EPS.
Yep.
And also looked at how to make it more environmentally sensitive and aware. And so their research took them to developing a graphite bead that is put into the normal process of doing polystyrene. And the graphite bead, what the graphite does is highly reflective.
Yep. Okay.
So that roof will reflect the heat or the cool back into the house or off the house.
Yeah. From the external effect.
Yes.
Yeah.
So now we've got a material that all the research and all the testing proves that it provides 20% better R value
Yeah.
for the same thickness of material.
Yeah.
So,
And why wouldn't you have that?
yeah,
Yeah.
well,
Yeah.
what it means is that you can use a 114 thick wall.
Yeah. Which we've actually got here. We can show that too, which is very similar construction. It's just this happens to be a thinner section, a thinner profile for a wall build-up.
Yeah, so now we've got a 114 thick wall with near pore insulation, and that wall's producing an R value of 3.9.
Yeah.
And as you know, Andrew,
It's about double.
yeah,
If a wall's quoted at 2.5 in a conventional house, it's probably not going to achieve anywhere near that. It's going to have gaps, at least gaps every 450 mil. It may have been squashed in. Realistically, you're probably getting R2, maybe even a little bit less.
yeah,
Whereas this method, it's continuous throughout the whole envelope.
yeah, and to get R 3.9, you typically need to go to a 140 wall.
We would go to a 140 stub wall. Yeah, that's sort of the standard for a passive house timber frame construction. We step up to 140.
Yeah.
Correct. Yeah.
So and the walls are the same. So same material. The only difference is the thickness of the panel.
Yeah. And easy to
Easy.
build.
Fast. Yeah.
I mean, two guys can pick up a section of wall effortlessly. We've recently tried it, and I think on one particular wall, when we nutted it all out, we had one section of wall built in 2 hours. I reckon if we did it again and it wasn't raining, we'd probably do it in an hour and a half, but that's what we're up against that day. So the other thing that's coming into Australian building codes is the earthquake loading.
Yeah.
Pretty new in Australia, unfamiliar to a lot of builders, engineers, architects. I've seen it creeping into some documentation from time to time. It's coming. SIPS, it sort of solves that problem, doesn't it?
Well, it does. Structural insulated panels meet the earthquake code of California.
Yep.
And exceeded in many cases. So we recently been quoting a project in Tonga, the island of Tonga, for
highly earthquake prone.
Yep.
Yeah.
And not far away from the San Andreas Fault. Not only are they earthquake prone over there, they're Hurricane 4 category.
They've got everything, haven't they?
Yeah. And so the SIPS meets the earthquake code of California. Already built into the panel. We're not doing anything different. There'll be some extra tie downs, but the panel for all intents and purposes is the same.
And for our needs in Australia, whether it's earthquake or wind loading, we don't need those extra tie downs.
Yeah.
Essentially, the way it works is each panel to the adjacent panel and to the floor and to the roof is continuously nailed and glued, similar to the way we do applied bracing, but it's the whole structure.
Yeah,
So,
and on both sides of the wall.
Yeah. So it's essentially double the bracing.
Yeah.
But maybe even a bit more, because this is, what's this, Peter? 12 mil or 14 mil?
11 millimeter OSB 4,
Yep.
which is an interesting point to talk to. Most SIP suppliers use OSB 3.
Yep. OSB 4 is the next level.
Yeah, so it's denser material.
Yep. Different glues.
It's VOC free adhesives.
Yep. An absolute bonus, that one.
So no formaldehydes.
Yeah.
And has better water wicking and capabilities. So if you're constructing,
Which is relevant during the construction process, because no matter how hard you try, there's always a chance you're going to get a bit of rain.
And the other thing that it is more airtight.
Yep.
And so when we're going for a high level passive house like you build,
Yep.
particularly in a small house, it's very hard to get the airtightness.
Yeah.
Right.
Per volume,
Yeah.
the smaller the house, the harder it is to achieve that 0.6
Yeah.
air changes per hour. So
Yeah.
the SIPS is, well, we'll find out soon enough what our rating is. We're going to do a blower door test in the next couple of weeks, but I think we'll smash that 0.6 quite easily. Yeah. So the other thing then, Peter, is lifespan.
Yeah.
What can you expect out of a SIPS panel construction?
So typically we design the houses for 70-year life, and that doesn't mean to say in 70 years it's going to fall apart.
Yeah.
That's the design life.
Yep.
Design lives are usually a third of the actual life.
Yeah.
And so what could happen to the SIPS house in 70 years? Uh, like all houses, if the owner doesn't maintain the claddings
Yeah.
and they let the elements into the materials, then they'll deteriorate.
Yeah. Yeah. I mean, in terms of that, it doesn't matter what you build,
Yeah,
where you build it, if you don't do your minimum maintenance, which is going to be specific to the building materials as well, particularly the cladding and the windows. If you're not doing that,
yeah,
it doesn't matter how
yeah,
good you build. That's
yeah.
still your obligation as the owner.
That's
So
right. Yeah.
yeah. The other big thing that I've found on site with the SIPS panel construction, it's fast. Like we're talking 1 week, floors, walls, roof, 1 week. And if you're able to bring another guy on board and speed up that process, you'd easily incorporate into that 5-day period all your building wraps as well, and you'd have your structure wrapped up watertight in 5 days.
Yeah, we see that all the time, and it surprises the builders greatly.
Yeah.
And it has follow-on effects for the construction project because
Yeah.
if you're reducing your time to lock up, your scaffold hire is reduced.
Well, I'll give you an idea. We've got rough-ins underway now.
Right.
We finished building a SIPS frame and all the internal frames in 5 days, and now in week 3, we've got plumbers and sparkies starting.
Yeah, it's fantastic. And because of the nature of the material, you can be on the outside while they're on the inside.
Exactly. Yeah, I mean, typically with a passive house, we want all those internal trades finished, all the services run, so we can test any of these penetrations for air tightness before we do our external cladding.
Yeah.
I guess one of the cons is you do need to allocate that time to say design the building, because these have a bit of a lead time. You don't get that with a conventional house. A conventional timber frame, you can go down to the shop and just pick out the material and start. But what is a typical sort of lead time for these panels?
Okay, so at Smart SIPS, we have 2 lead times. So the first lead time is the design time.
Yep.
And so we'll get involved with the architect or building designer at the same time as they would normally engage the engineer.
And that process is going to be the same whichever construction method you're choosing.
That's correct.
Yeah.
So, and during that time, we're developing, we call them working shop drawings. And the difference between a shop drawing and an architectural drawing or an engineering drawing is that we combine all the engineering and the architectural into one page.
Yeah.
And only look at the SIPs. We're only drawing the SIPs and the associated materials.
Yeah.
We're not looking to put in the windows and all that. So we're specifically developing a shop drawing in our preliminary works process that gets the building completely designed up to ready for production.
Yeah.
And our 3D model goes directly into the factory, and we cut. We use CNC equipment to.
Yeah. So you're talking everything's millimeter perfect.
It is, yeah. And you would have seen that on the build you've just done.
Yeah, I mean, the only thing that we had to learn a little bit on that one was actually allowing a little bit of wriggle room in there. We did have the problem of I guess it's by nature of carpenters, you want to do tight joints, but actually you need to allow a little bit of construction gap. So, but easy to overcome. So then the lead time from when we say, okay, we've decided on the design, when can we have it out on site?
So our lead time's 10 weeks delivery from factory, from time we place the order on the factory to when we deliver on site.
Yeah.
And that's for all over Australia.
Yeah. Right. Yeah. So from a builder's point of view, really what changes is the schedule.
Yeah.
And for a lot of the projects that we do, they're greenfield projects. So we've often got to do a septic system, maybe a driveway, some drainage, some concrete pads for a water tank, for example. We'll still go ahead and do all that. We'll do our footings, and in this case, we've done our bearers while we're waiting for this. So the lead time's got to be factored into it. You can't ignore it. But most of the time, other things can be going on as well.
Yeah, and because we've got good working, good shop drawings, and everything's computer cut, you can go ahead and do all your foundations. And get all your subfloor ready, or your slab.
And work off the same shop drawings for the subfloor framing.
That's right. Yeah, you use our shop drawings for the setouts.
Yeah. I think the other thing we didn't actually touch on when we're looking at this OSB, which is similar to plywood if you're not familiar with OSB, because we're connecting everything together continuously, we don't have these little triple grips and bits of tie down strap which plasterers hate, and if they're not installed correctly they're just worthless. So that to me, from a building point of view, is a huge bonus. We're not having someone running around adding bits of hardware. It's all incorporated. As for the lintels as well,
Yeah.
all our lintels, we're not having to get carpenters on site to work out what size lintel goes in what opening. It's in there. It's already done.
Yeah.
Yeah.
Yeah, you just pick this up and drop it into the pockets we put either side of the window.
Yeah.
Just touching back on the OSB.
Yeah.
OSB orientated strand board. How that's actually manufactured is that normally when in a sawmill, when it's cutting up lumber, if you're doing solid timber, you can use maybe only 40% of the tree. Well, orientated strand board, we can use 80% of the tree.
Yeah. Picking up all that waste material and turning it into something.
Yeah, exactly. Yeah. And likewise for the nearpore, that's made out of a biofuel base, and only and 80% of that nearpore is air.
Yeah.
Okay, so
which factors into the R values, the insulation values of this product, which is, I think, probably the last point to touch on is the energy requirements for a house built with SIPs, where we've got, what are we saying, close to R4 in the wall, so double a conventional house. We're talking R11 in the floor.
Yeah, R11 in the floor for this thickness floor,
which is more than double most houses. So what does that mean for energy costs, running costs, and I guess also comfort when you're in this house when it's finished?
So yeah, it's a fascinating question, because when people are ready for being in a high performance home where it's going to be comfortable and
all year round.
Yeah. But there's a few things that they're not ready for, and one is that because there's no air leakage, with the SIPs you're going to get one air change per hour straight out of the box, and then tape the joins, good quality windows. You're going to get down to your 0.6 for passive house. We recently did a house in Canterbury and we got 0.21 air changes per hour.
Which is almost a little bit too tight, isn't it?
Yeah, well,
which is an easy problem to overcome, though.
Funny thing is, the builder and the architect were running around trying to find the leak at 0.21. So
you've won. I mean, at that level, you could just walk away and say, "We've done it. We've nailed it."
I told them I weren't building a submarine, but so what does it mean for what does that mean for the homeowner? Well, the first thing is, and people don't factor it in their initial thinking, is that you're going to reduce your heating and cooling by 90%. Compared to a conventional house built to code.
Yeah, again, it's the fridge analogy.
Yeah.
When it's well sealed up, when it's well insulated, a small amount of energy to bring it up to temperature in winter or bring it down to temperature in summer. That's it. They turn off. The air conditioner's not running all the time. The ducted heating, it's not running all the time. It just brings you to the temperature that you want, and then it's shut down.
So but 90% less running costs for heating and cooling.
It's a huge saving.
However, that translates into, I don't need such large heating and cooling equipment in my house.
Another saving.
So generally your heating and cooling equipment, your infrastructure costs in your house is going to be reduced by 75% in cost.
Maybe even a bit more. The SIPS panel that we've just finished recently only has 2.2 kilowatt split systems. That's heating and cooling. And I'd be surprised if they ever have both of those running at the same time.
That would be right,
Yeah.
And because there's no air leakage in the house, normally if you're in a conventional house and you heat one part of the house, the other part's
cold.
Yeah, the other part's cold. With a SIPS house, it's the same temperature all around.
Yeah, and also you've got the HRV system in there that's mixing up, stirring up all that air as well. So there's no cold or hot pockets in the house. It's consistent.
And the one comment we get, the two comments we get from the people who move into their SIPS house, is the first thing they go, "It's so quiet."
Yeah.
Because it's not leaking air.
Yeah, not leaking sound.
And it's insulated better.
Yeah.
And the second thing they get, and they can't explain it, and we had one guy who actually suggested that it was like being in a house with a blanket wrapped around you.
Yeah.
Because we're getting the heat is radiating back off the walls, and so they just feel warmer because we're getting a radiated heat, and so it's quieter, it's warmer, it's less costly to run. It's just a better house.
And I think the acoustic value is one of those things that it's not why you do any of this, and it's
Yeah.
not a figure that people are readily going to quote, because what we're really interested in is energy and comfort. You know, a better build all around. The acoustic values is just a bonus.
Yeah, it is.
And some places you might not notice it, but I think generally, even if you're out in the country, you're going to notice you don't hear the wind so much.
Yeah.
But if you're living in the suburbs, all that traffic noise, that's gone as well.
Yeah, if you're close to an airport, my house is right underneath the flight path,
Yeah.
the northern suburbs of Victoria,
Yeah.
and that meets all the acoustic requirements for the airport for noise control.
And isn't that a good location to test out that effectiveness too?
Yeah.
It doesn't get much noisier than that.
Yeah. There's all these added benefits that come just from switching construction systems.
Yep. Yeah. And doing some forward planning as well.
Yeah, exactly.
That's the thing. I think that always ties into any good project is anticipate some forward planning. Don't be afraid to do that. Spend the money on these documents and the right consultants, and the project goes together smoothly. I mean, it's common now where we can spend months and years in planning and documentation process, and then within a couple of months we've built something.
Yeah, you have.
So that side of it's gotten easier because we've got the good information. We've got a plan.
Yeah, and then so if you're building a house and getting it to lock up 40% faster, you know, in Australia today, the conversation is how are we going to build more houses?
Yeah, and quickly and efficiently.
Yeah.
Yeah.
And meet the new codes coming.
Yeah, the codes that are about to land on us now, I think there's a lot of consultants, builders who are not going to be quite ready for that.
No, well, there's a lot of old builders leaving the industry.
True. Yeah. So we're sort of, hopefully with a system like this, we're also future-proofing as well.
We are.
Yeah. Brilliant. Good stuff. Thank you so much for joining us, Peter.
You're welcome. Thank you, Andrew.
Thank you. So that wraps us up for another episode of Building Australia. Thanks for joining us, and any questions, just reach out.